Go.
Hello and welcome to the physics lab. Today we're going to measure resonance. And in the background you can see Haley. Say hi, Haley.
Hi, Haley.
Hi, Haley. All right. She's not a lab assistant today because we actually only are allowing competent people in the lab today. I mean, for the videos. All right. So there's 3 parts to this lab. 3 parts. Pick number 3, my lord. Anyway. So in the first part, we're going to figure out what our inductance is. All right. An inductor is also known as a coil, and this is jobby right here. Okay. See that? So this is how we set up the circuit. We have this thing here, which is called a resistance decade box, which is also think of as a variable resistor. All right. Instead of picking out resistors, we're going to just use this, and we set it to 5,000. That's a 5. Which is bigger than 4 and less than 6. Okay? And all the rest of them should be at 0. That's important. Okay? So the signal comes from our oscilloscope, the signal generator part of it. It comes out, splits. Half of it goes over here. The red one goes over here, through the inductor, back out the circuit board, over to the decade box, and then back to the signal generator. That's our circuit. Okay? What we're interested in doing is we're going to be interested in measuring the voltage, the DC voltage, across
AC.
Also known as AC voltage, not DC voltage. I'm sorry. Thank you, Greg. The AC voltage across this decade box. Now, the first point we're going to take, we're going to set the signal generator up. And really all you need here is the waveform generator. We're going to set it to 800 hertz, which it already is at. And then what we're going to do is we're going to adjust the amplitude until we get exactly 1 volt. Like right now it's at 1.5 volts. So we're going to go down. 60. Oh, that's 1.175. 49. That's a little bit too low. Or I could just type in 51 because I know that's where it's going to, on this particular setup, it's going to come out to 0.999 volts. All right. So now we've got that data. Then what we do is we measure the voltage across the inductor or coil. And you can do that like this. And I got 0.106. Trust me, you don't have to look at the... So then what I do is I fill out my sheet here. So I have 1 volt across the resistor, just like I expected. I say it's 0.106 here, so I type in 0.106 for the coil voltage. And the signal generator voltage, I can measure that. Where can I measure that? I can measure that from the red here to the black on the signal generator. And that came out to be 1.026 volts. See that? It's just the 2 leads coming off of the signal generator output. Boom, like that. All right. So then what I do is I repeat that, but at a different frequency because there wouldn't be much point in just leaving everything the same. Now we're there. That would be dumb. We're not going to do that. I'll leave that to people who don't. Your lab partner probably would do that, but you wouldn't do that, would you? Okay. So then we would do it at 1400 hertz. So we go back to our signal generator, and we set it to 1400. 1400. And then we are going to adjust again the signal across here. It's not right now. It's hard to do this one-handed, by the way, but that's all right. You'll have a lab partner. And we'll just jack that up to 52 for now, if I can reach it. And I'll probably get it right on. Ooh, very good. I'm so good at this, aren't I? And then I get my voltage across the coil, which I can get down here, 0.178. And I get my voltage across the signal generator, which is 1.04. I fill all those out. Now the calculations that you do are all in the spreadsheet or in the lab manual. But you'll figure out the current. Now you might say, oh, well, I thought you told us we weren't going to be measuring current anymore in the lab, so we didn't have to worry about blowing up any fuses. Well, I'm right, because I said you calculate the current. All right, you don't have to measure it. Then you figure out the inductive reactance and the inductance in henries. Not Bill's or George's, but Henry's. All right? You do it for 4 frequencies, and then you average them. Okay? You got that? All right. Now for the next part, we'll be right back with how you measure the capacitance. And I'll see you in the physics lab.